Good God, what a depressing sight. All right, so here we go. Limits. We've got limits going on, and here's our limits. So we're going to go over and talk about the different types of limits. I'm not going to spend a lot of time on limits. I just need you to know that a limit is basically converging on one point. Because we need to get into the derivatives, and this is calculus. This isn't, I don't want to spend a lot of time on derivatives, but we're going to go through the different derivatives. No matter what, the convergence, and this is squeeze theorem. They don't call it that yet because technically we haven't had enough calculus yet. But if you take, if I can get this to work. Well, there. No matter what x is converging on, if x is converging on 2, then the purple, the y, you're converging on 1.5. If you're converging on 3, what's your y converging on? 1.75. If you're converging on 5, or 5, which would be right there, you're converging on 2.25. So the actual limit, when you're given a limit, and they say x approaches, I'm trying to find a nice number here, and it won't let me. Well, 600. When x is approaching 600, your y is approaching 152 or 151.6. When you're approaching 2, your y is approaching 1.5. When you're approaching 1, your y is approaching 1.25. Now, that's if you're coming from the left or the right. Now, I want everybody to draw this picture at 2 and 1.5 on your notes. Please do that so when I draw this, you'll be able to put it in your notes. You need to make it a little bit bigger. I would say 1 unit to the left and 1 unit to the right. Because I'm going to go through and I'm going to explain the different limit processes. And one is going to be converge, what I'm talking about now. I'm going to talk about piecewise functions. We talked about that in the review. Then I'm going to talk about algebraic, where we have to factor. I'm going to talk about those 3 main things pertaining to, pertaining to limits. And right now we're going over the convergence. So if I was doing a limit here, that limit as x approaches 2 from the right and left. Now that's what the positive and the negative means up in the top right hand corner, or it'll be on the left. I don't care. Probably will be on the left. If I say limit as x approaches 2, from the right, that would be this side. If I say limit as x approaches 2 from the left, that will be coming from this direction. Either way, the answer to the limit as x approaches 2 from the left and x approaches 2 from the right, the answer is what? 1.5. So when you're talking about a convergence, they're going to say x is approaching a number, and you're going to answer y. Now, the purple and the blue, the purple and the aqua regions are basically teaching you the squeeze theorem, that if the blue converges onto 2, the purple is going to converge onto 1.5. Now, I know some of y'all are saying, well, golly, that's easy to know. Well, you'll be surprised on how many people have gone through algebra and calculus and don't even know the squeeze theorem, or what it's called. So no matter what I do on this function, it's going to converge on a number. And that's the main thing I want you to see with this graphic. This is one type of, I'm trying to get it to move again. There. Well, no matter what number, okay, watch that speaker. No matter what number I get on, whether it's 3 or whether it's whatever, 33, 85, 91, it's going to converge on whatever number the function dictates. Depends on what the function is. Okay, so let's go to another one. All right, you draw this one in your notes. This is a piecewise function. I want you to write, here's f of x is equal to x. Write that down. F of x is equal to negative x plus minus 4, quantity squared plus 5, and f of a is equal to 1. And there's your 3 functions or points or whatever. Just draw a picture of that piecewise function. And this is the second type of limit that you're going to see. So as I approach whatever number this is, looks like, well, there's 4, there's 3, 3.5, looks like 3.7. I don't know what it is. But as I approach, okay, 3, I'm sorry. As I approach 3 from the right, I'm approaching 4 with the blue line. So go ahead and finish writing this down. I just want you to see that. Because do y'all know the whole reason we're going over limits is to get your mind thinking, I'm taking my distance from that slope, I'm getting my distance down from 5 units down to 1/100th the width of a hair. Now, for some people, it takes a whole chapter for you to get that in your head. For some people, it takes 5 minutes. Okay? It's called thinking out of the what? Box. And that's why you spend a whole chapter on limits. Now, I'm not going to spend a whole chapter on limits. We're going to spend about a week. That's about it. And we're going to move on. So I'm going to be very selective of my test questions. They're going to be very, and I wouldn't suggest doing any homework yet on chapter 1 because I may go through and I may change the homework. Okay? So just wait on doing any homework right now. All right. So there's your function. You're approaching from the right. So as x approaches 3 from the right, you're approaching 4. As x approaches 3 from the left, you're approaching what? 3. So this is discontinuous. Why? Now, if you were approaching 4, then it would be continuous. But since you're approaching a different number, it is discontinuous. Write that down. And of course, you can't do much with A because A, when A is 3, you get whatever that is. There's not much convergence here. Does everybody understand the convergence part? What do you mean somewhat?
I mean, it's making pretty much sense. I get what's going on.
That's why I leave it up here. Because if you look at that over and over and over, you start to see the squeeze theorem on the green. Now it doesn't have the right-hand side, because the right-hand side is the blue. It's a different function. So you can go back and forth like that. And as that one converges, it's converging on 4. As this one converges, it's converging on, so there you go. Okay, now look at it. Are the two dashed lines, are they meeting? No. You may say the vertical line is, but what about the horizontal line? No. One ends at 4 and the other ends at 3. So therefore they're not continuous. Question, gripe, complaint. So far you've got a convergence using the squeeze theorem on a continuous function. The continuous function is this one right here. A discontinuous function, and we're going to get into that in just a second, is this function right here. Question. Again, here we go. We got another function. This is the same function, or close to the same function. I don't know if it's the same or not. Look at it. You got x plus, or x minus 1, and then you got negative x minus 4. You know that's the horizontal shift of 4 to the right, and this is a vertical shift of 5 up. And you know that it's opening downward, and you know it's a parabola. So that's why it looks like this. Now, x is greater than a. It's right here. I'm going to make this, well, let me make it right there. Is f continuous at a? No. Why? Somebody tell me why. That means I want you to communicate with me. Why are they not continuous? They don't equal on the y. The y on the blue is 3.14. The y on the green is 2.14. They're not equal. So you need to write that down. That's all continuous is. You'd be surprised on how many people make it difficult. Pendleton, do you see what I'm talking about?
Yeah.
Appreciate it, one person. Are you representative of the Pendleton campus?
I guess so. Today I am.
Are you the captain? Or are you the? Settle down, Pendleton. I tell you what. Easily. Do you see what I'm saying?
Yes.
Yes. Yeah.
How about it, Mr. Miyagi?
Yeah, yes, sir.
Are you awake? Are you watching?
Dude, I got home from the gym at like 11 last night and watched 7 hours of 7 episodes of The Witcher. I don't think I'm like here.
Okay, well you can watch a video later. Mr. McCullough, what's up with you? Why didn't you go to the Pendleton campus today?
I just don't really like them anymore.
Okay, all right. And Miss Frady, she woke up with a hangover this morning, so she's not feeling good. All right, she's got the crap or whatever. All right, here's another. Okay, hide answer. We're going to do that one. Second question: is it continuous today? No.
It's not the same question.
Well, that's the same question. I don't know why it's supposed to change it. There we go. Is this continuous? No. There should ask you if one is continuous. There we go. But it's not because you got an open circle. Okay? And you can go ahead and do both. But the problem is you've got an open circle. You've got a limit, but it's not continuous. Write that down. You've got a limit. What's the limit? The limit is the y value. What's the y value? 1. So it's very important that you understand this. You can have a limit, but because you have an open circle there, that means it's not continuous. So write that down. I hope you're writing it down because these are your test questions that I'm going to ask you. I'm going to give you one that's not continuous, and I'm going to give you one that's continuous. I mean, that's not continuous but has a limit. And in this case, the limit is 1. As x approaches 3 from the left and right. That's your squeeze theorem right there. The blue and the green converging onto 3 from the left and the right converges to 1 on the y-axis. And hopefully, with me showing you these 3 graphics, you should be saying, some of you should be saying, I understand what a limit is now. Because sometimes it only takes a picture. Let me ask Pendleton, since y'all talk all the time, is there anybody up there that has never understood limits that maybe you're starting to say, was that all it is? Anybody? Okay, they're not going to say anything. Easily, how about y'all?
I think it makes more sense than the graph.
Thank you. I appreciate your communication, Miss Billy. Jake, you're not going to say anything?
No, I mean, it's helping a little bit. I'm still a little confused.
Tell me what you're confused about. Pendleton, are you confused about anything?
No.
I'm just going to go on to Mr. McCullough or Miss Frady or Mr. Miyagi. Y'all got any questions? Does it make sense better when you look at the graphics on the squeeze theorem and going together?
Yes, sir.
Yes, sir.
I thought it'd be more difficult.
Basically, that's it, except for the algebraic. We ain't got to the algebraic yet, but I already showed you a little bit about that. Either it goes or you're going to have to factor one of the two. All right, the last one. Now, is it continuous? Yes. And there's your 2 or 3 questions I'm going to ask you on the test. So that means that 80, 90% of your test is going to be algebraic limits. And only 20% of your test is going to be on continuity. So I just gave you 4 or 5 questions on the test. I gave you the squeeze theorem. What is happening when something approaches 2? When x approaches 2, what are you approaching on y? That's a question. All right? That's called the limit. The 1.5 is the limit. Okay, that's one question. Another question. What does it mean when you have a positive and a negative? Well, that means left and right. Well, there we go. I'm approaching from the left. There's the negative. And I don't know why it's not showing. There we go. And approaching from the right, that's positive. So that's the question. I'm giving you these questions again so you can write them down so you won't miss them on the test. The third question, continuity. I'm going to give you 1 or 2 of these. I'm going to give you one like that, which is discontinuous or not, no continuity. Then I'm going to give you a continuity with a limit, discontinuous, sorry. And then I'm going to give you continuity with a limit. So is that 5? It should be 5 questions. 5 questions right there. Now, there's another question, and that is limits with infinity. This is your vertical and horizontal what? Asymptotes. You don't have any open circles here. Does everybody see that? Now, what happens when you have something as x is approaching from the right? You leave the vertical asymptote and it just keeps going. When it comes from the left, when it comes from the right this way and approaches 0 from the right, you have infinity. Same thing on this side. There we go. It needs to go the other direction, but I don't know why it's going that direction. It needs to be going the other direction. As x approaches infinity as x approaches negative infinity. That's all I can do there. Now make sure you make a note of this one because 1 over x and 1 over x squared is used a lot with these questions. So tell me what is happening as x approaches 0 from the left and the right. Your limit is undefined, does not exist. So, limit as x approaches 0 from the left and right, the limit does not exist. Why? Because the limit is the vertical what? Asymptote. You never touch that axis. You never touch it. Actually, you never touch 2 either. That's the horizontal asymptote. But when we're talking about x, we're talking about as x approaches, here comes x, as x approaches from the right, boop, and it doesn't touch, and then it takes off, and from the left, as x approaches from the left, you start getting closer and closer to the wall, but you never what? Reach it. And that's question number 6. What's happening to the limit as x approaches 0 from the left and right? You have a non-existent limit. Does not exist. Question, gripe, complaint. Why are y'all not talking today? What did I do to piss y'all off?
I think everyone's dead.
Why? I mean, there's no football. There's nothing on TV worth watching. What? Did y'all see a good movie this weekend or what?
Yeah.
Well, I watched Kobe Bryant's final game last night.
Jesus Christ.
They played it back on Sports Center.
Well, maybe they'll play it 24 hours. Whatever. Okay? And
You weren't a Kobe fan?
Any good movies?
Watch The Witcher, all of this season. Episodes. It's great.
He's already said that once. I think he's okay? So we're not going to talk. Miss Miyagi's high, so let's just not talk about it.
Correction, crossfaded.
Okay.
Oh, what does that even mean?
He's canceled. Okay, since y'all are not going to ask anything, I guess we'll just move on. I guess everybody knows limits now. There we go. Thank you. That's what I was trying to get y'all to understand. Let me open it up even further. There we go. There. That's what I was trying to get y'all to understand. As x approaches from the right, well, let me reset it. Oh, crap. Hold on. I'm doing this for y'all. I could just go through and not even cover this material, but, you know. Here we go. Hopefully let's count down. See, as x approaches 0, there it is. I wish it'd go slower, but it's not. There it goes. It never touches the vertical asymptote. And that is the closest thing. Was that a call for a question? That's the closest thing to approaching the wall, but you never touch the wall. And that's question number 6. So let's get to the other questions pertaining to algebraic. And that's what they're showing you here, here. They're showing you how to write as x approaches a from, I want you to write these down. As x approaches a from the left, as x approaches a from the right. And this, as x approaches a from the left and right. Or they might some books put plus and negative. Either way, you're basically asking, what is the y value when A is coming from the left and the right? Not a big deal. Just make sure you know how to write it.
Did you know the road in front of Oconee campus is called Hubert Drive?
Yeah, they did that because of me.
Mm-hmm.
Yeah.
Hey, can you go back a slide? I wasn't done writing that.
Actually, I got an uncle in Townville, and double Springs because you can't mix the two. And there's a McClure Drive over there, and my uncle keeps knocking down the. He's not a McClure, and he keeps knocking down that sign. He used to. He's dead now. But anyway, it was named after my father, and my uncle knocks it down whenever he used to. Whenever he was on the tractor, he would knock it down. Anyway, yeah, they named it because of me. Anyway, look at this. Write this down. This is a test question.
Well, can you go back to the last slide? I wasn't done writing that down.
I'm sorry. I don't really like you, Jake, so I don't care. Yes, I'll go back. Hurry up, Jake.
Sorry.
Pendleton, are you still writing, or are y'all watching porns up there? Because I don't know what y'all are doing.
Has anybody ever been to the last page?
What is he talking about?
Dude, I don't
know. Is the sun blue with cheese? I don't know, man. Does alligators have teddy bears? I don't know. All right. Are you finished, Jake?
Yes, sir.
All right. Now write this one down because this is the type question that I would give you on a test. Now, what you should be able to do with these questions, I want you to graph it on your calculator so you can see what's happening. I want you to sketch it, and I want you to answer the questions. Well, I'm going to go pull up my handy dandy calculator. And while y'all are writing that down, I'm going to pull up my dang old graphing calculator, and I'm going to graph x squared minus 9, x squared minus 9, no sneezing in class, divided by x minus 3. Now, what can somebody tell me about this problem? It's a rational function, right? So what does that mean? That's supposed to be divided by dork. Give me a second. Unmute. Second insert. Okay, what can y'all tell me about this rational function? What cannot go in the denominator?
Negative.
0. So therefore, if you want to find the vertical asymptote, you set the denominator equal to what? 3. Yeah, 0, which you get 3. So if you get 3, write this down. If you plug in a 3 right here where it says what is f of 3, if you plug in a 3, the function is going to blow up. Now I said blow up, so that means that y'all can report me for being a terrorist. Okay? But in Mathematica, in the world of mathematics, and I don't know how many professors you've had in mathematics, but I know I had 3 at Clemson that would say the function is going to blow up. Okay? So if I'm a terrorist, then those 3 are terrorists, and one of them's dead. I don't know where the other ones are. I think Dr. Ruckel, he's probably 137, and he's probably still playing Tetris in his office at Clemson. So they may have put Dr. Harden in a coffin and put him in the office. I don't know. And locked the office. They did put a plaque beside his name. He was the one that grunted. Remember me telling y'all 109, the professor that grunted all the time? Yeah. When y'all get to Clemson, y'all gonna have some real interesting professors.
We already got one now.
No, I don't know about that. I'm just redneck. All right, what is the limit of f of x as x approaches 3? It does not exist. Let's look at it. Graph. Okay, and go to the table, second table, and what happens when you get to 3? Got an error, or if you're not from around here, error. Powdersville. I live in Powdersville. Jake, what is a green wave?
Hey, I have no idea. I guess somebody puked at the beach.
Every time I think of Easley Green Wave, I think of a swimming pool that hadn't been cleaned. And you know how the water turns green?
Yeah.
That's what I think of. Why don't you research that and tell us where Easley got the name Green Wave?
I'll do it.
Did you go to Easley?
No, I went to Piggins. Piggins and Easley are like rivals.
And they're Blue Flame.
Of course.
Best place I ever played was the swamp in Pickens. And it just had rained like 3 or 4 inches. I don't know if y'all changed stadiums, but back then they had the Blue Flame coming out of the scoreboard.
Yeah, you talking about Bruce Field down in the hole?
Yeah.
Yeah.
By the time we got through, we all looked like, we couldn't even tell each other's. It was awful. It was just mud. That was the best football game we ever played. We beat the crap out of y'all. It was
Whatever.
Like 41-3.
No chance.
Okay. Yeah, that's
Where'd
right.
you go
Nobody beats
last
Pickens, right?
Well,
All
they
right,
do now, but not
what
back
else
in the
can
day.
you do here? We can actually take our handy-dandy algebra, and this is the questions you will see on the test. X plus 3, X minus 3, and then divide by X minus 3. And then what happens to the X minus 3's? Now, what happens when you do the limit as X approaches 3 now? You get what? 6. But I doubt they'll ask that on this one. They may. Let's see what they do on this one, because yeah. They plugged in, they got the function blows up because you can't have 0 in the denominator. So f of 3 does not exist. That's why we have an error at 3. So there'll be an open circle. If you go to that function And I'm not trying to, if you actually blow that function up, I'm trying to get there, just hold on a second. Let's change the zoom. What's 3? 6. So let's zoom in. No, let's change the window to X-min from 1 to 5. And 1, 2 to 8. And graph. Y'all see that little dot right there? I'm going to pull in even closer. And I don't know if y'all can see this, but right there in that line right there, see right above the cursor, there's no line right there. I'm going to blow it up even further. Do you see it?
I just think your graphics are bad.
No. Everybody see it right there?
See it?
Okay? That is an open circle. And you need to write that down. This is an open circle because you can factor this x minus 3 out. If you can factor the x minus 3 out, it's going to be an open circle. If you can't factor the x minus 3 out, that's when it becomes a vertical asymptote. I hope you understand what I just said. Let me go here. And what they're doing now is showing you what's happening. And you can fill this out if you want to. Put this in your notebook. Okay? Basically, they're showing you that there's an open circle on the graph. As x approaches 3 from the left, you get 5, you get 5.5, you get toward 3, you're getting toward 6. Remember me telling you the limit was 6? Well, they're showing you here how that's happening. But what they're going to do is show you algebraically here in a second, taking out hopefully they're going to take out the algebra and factor it out. Okay? Hopefully. They're not going to show you. All right, let's look at this function. I want you to draw this function. So it's give y'all a couple of minutes to draw that function. It's a piecewise function. They're 2 straight lines, so y'all shouldn't mess it up, except for Jake.
You've got no faith in me.
None.
What is that dot above the 1?
Oh my God. What'd you say, Jake? I'm sorry. I was reading an email.
That's kind of rude.
Yeah, it is, isn't it? What'd you
Yeah.
say? Actually, I was reading the email when you should have been graphing, but go ahead. What?
Well, I was wondering what that dot was above the 1.
It's not supposed to be. I don't know what that is. Hold on, Jake. I'll try to take care of that for you, okay?
I appreciate it. So I threw this in a calculator and it said error. Blowed up.
Yeah. Well, I don't know if I can take care of it or not. I'm trying to. Things I do for y'all. And it's not appreciated.
I appreciate it.
Well, I can't do it with the mouse, so.
Did the dot bother you that much?
There. Is that good, Jake?
Yeah, that's a lot better.
Okay. Mr. Miyagi, you're fine. I don't want you to have to think, Mr. Miyagi. Just stay in balance, okay? Just balance. We don't want you to end up like grape. Squish like grape. So we got a function, and we know that the function has got a y-intercept of 2, and 1 to 1, 1 over 1, 1 over 1, 1 over 1. We know we got a line that looks something like this. Okay? X is less than 1. So that means that I've got to erase. Here's my 1 right here. It's supposed to be red. There's my 1 right there. So I've got to erase everything to the there. And I have a, what kind of circle do I have at the end of that function? Okay, everybody good? All right, now I'm going to do the other one in blue. -4, 1, 2, 3, 4. And we got a positive slope, 1 to 2, 2, 2, 2. And everything to 2, everything is this way. And what type of circle do we have there? Close. All right, somebody tell me what limit x is approaching, limit as x approaches 1 from the left. What is my limit? Well, let's plug it in. What's 1 times 2? 2. 2 plus 2 is 4. What is the limit as x approaches 1 from the right? What is it? Be -2. Are these two equal? Does the limit exist? Is it continuous?
No, it's not continuous.
It's not continuous, and the limit does not exist. Simple as that. I'm going to warn you. There are teachers that will explain to you limits and will lobotomize you before you leave the classroom. I'm trying my best, but I have no communication from y'all, so I guess y'all understand it. I don't know.
You're doing pretty well.
Thank you, one person. I appreciate it.
This seemed a lot harder in the other classes.
Yeah, but you're high, so we can't take your word.
Sleep deprived, bro. Sleep deprived.
Sleep deprived, okay. Pendleton, do you want to add anything? Easley, you want to add anything? Mr. McCullough, anybody want to add something so I can get some kind of feedback?
You're doing great.
Thank you. Whoever said that. Must be from Pendleton. They don't want to get beat up.
That was Miyagi, bro.
No. Okay, well, we're just going to keep going then. I guess they're doing what I just told you to do, right? Okay. Didn't we say -2 and 4?
Yes.
There we go. Limit does not exist. Why? Because -2 does not equal what? 4. That is a test question. Make sure you can do it. There's 2 test questions. I just gave you 2 algebraic test questions. And there's our 2 graphs. Okay, I don't know why they're doing this again. We've already. Sometimes they go a little bit too far. Okay, quit doing the drops. I appreciate it. Calculate the following limit based on the graph. The limit as x approaches 2 is what? 3. That's a test question. I'm not going to make this hard for y'all, okay? That's all it is. If you understand the squeeze theorem, that as I bring x from the left and I approach 2, I'm approaching 3. If I'm bringing, so the limit does exist. It is discontinuous because it does not jump over this little bubble right here. You don't have a dot down here or up here to cover that up. So the limit does exist. The limit is 3. That's all there is to it. And that's what they're, oh, look, we can draw a wall. They're using the wall. Wall spelled backwards is wall. Huge. All right, look at that one. Graph the function and find each of the following limits if they exist. So I just want you to graph it. I want you to find the vertical asymptote because it has 1. Because you can't graph 1. I mean, you can't factor 1 and cancel out x minus 2. Does everybody understand that? You don't have an x plus 4 quantity squared up there. You can't, or x minus 4, or x squared minus x squared minus 4x plus 4. You don't have that to factor. You just got a 1. So if you can't factor, write this down again, if you can't factor and cancel, then you're going to have a vertical asymptote. You're not going to have an open circle. You're going to have a vertical asymptote. So where is your vertical asymptote? Somebody tell me where the vertical asymptote is. At 2, Hubert. That's right. You should be able to tell me just by looking at it. I don't know how y'all expect for me to teach when y'all don't tell me nothing. I just don't expect, I don't understand. But evidently, y'all know more than I do. So I'm going to graph it. So y is equal to 1 divided by, I'm going to put that in parentheses, 1, well, parentheses, I can't hit parentheses, 1 divided by, parentheses, x minus 2, close parentheses, plus 3. And I better hit delete to make sure nothing else. I hate the TIA. Oh my God. It keeps backspacing. I don't want it to backspace. I guess that's right. Plus 3. Oh, now it takes it. Okay. All right, and hit graph. No, I didn't think it was going to like it. 1 divided by. There we go. Put in another parenthesis. Yep, I need to put in one more parenthesis. And zoom fit. Which one zoom fit? 0. Zoom fit. Didn't zoom fit. Zoom standard. There we go. And there is your vertical asymptote. How do you know it looked like this? Well, the parent graph of 1 over x. What does the parent graph of 1 over x look like? Half a volcano. So your parent graph looks like this. you know that this is a horizontal shift of 2 to the what? 2 to the right. And this is a vertical shift of 3 what? So my actual graph looks like this. 1, 2, 3, and 2 to the right. Oops, sorry. 1, 2. So, as x approaches what number? What's that number right there? 2, Hubert. As x approaches 2 from the right, what is my limit? Does not what? Doesn't exist. As x approaches 2 from the left, what is my limit? Does not exist. Now, it does approach 3 as far as y, but the limit does not exist because the vertical asymptote is at, 2. It does approach 3. Let's see. Yeah, 2. But it doesn't, or 3. It doesn't exist because of the vertical asymptote. And this stuff hopefully is making sense to some of you, even though you won't say nothing and you won't tell me if it's making sense or if you're confused. So I'm just supposed to read your daggum mind. Okay? So, yes, it looks like 4, but see, there's your vertical asymptote right here. Okay? They're saying observe the graph at 4. I'm not observing the graph. I'm showing you what here is your, I can't draw a straight line here, but there is your, oh well, forget it. There's your vertical asymptote, and your horizontal asymptote is at 3. Everybody see that? Vertical asymptote at 2, horizontal asymptote at 3. Now, what is the limit as x approaches 3? 4. What is the limit as x approaches negative 3? Maybe 2.98, 2.9, somewhere. What is the limit as x approaches 7? 3.1. Now, I could ask you questions like that, but what about when x approaches 2? The limit does not exist. And that's right, it does, because as you approach 3 from the, even though you cross over the vertical asymptote, you still hit squeeze theorem, you still hit 4 from the left, 3 from the right, 3. We should, this, I mean, after the first couple of times, good gracious. Okay, here we go. Limit does not exist. Now, it may say the limit exists since, well, negative infinity. Infinity is equal to infinity, all right? But negative infinity is not equal to positive infinity. So, in this case, they don't equal, okay? So, it does not exist, and I told you that from the beginning. Anytime you got a vertical asymptote, that limit doesn't exist. Oh, it makes sense, Hubert. Good, class.
It does.
Y'all act like y'all mad at me. I don't know what I've done. All right, there's your horizontal asymptote at 3. As y approaches 3, what is the limit for x? Well, that's non-existent. I don't think they're going to ask that. But as x approaches infinity, you're approaching 3, which is y. That's y right there. I'm not going to ask you too many of those questions. All I care about is that you understand what the limit is. Here's another question. I'd ask you to graph it and then draw a picture out to the right here so you can answer these questions. I was hoping they'd show a graph. but they love doing this for some reason. I would like for them to show the graph, and they're not going to show it.
Did you not make this PowerPoint?
Oh, Lord, no. If I made it, it'd be a whole lot direct and short and sweet. So that's it on that section. I'm just going to try to get us through these sections because I don't want you to do any homework yet. I know that's not going to be a problem, is it?
I've already finished it.
Got 2 people said something. I think one day I'm just going to come in and not say a word. And we're just going to sit here and we're just going to look at each other.
So like meditation? Heck yeah.
Pendleton, do y'all like meditating?
Yeah.
One person, yeah.
Show you how to wax on, wax off.
I'm not going to say a word.
And I'll bring a bonsai tree. I heard that's relaxing. It's like the sin
Very
of something.
much so.
See, y'all just. All right, here we go. Here's a parabola. All right, now I want you to graph this parabola on your handy dandy. Oh, Lord, hold on a minute. I want you to graph this parabola on your handy dandy calculator and tell me what the limit is as x approaches 4. Now, you can do it on your calculator or you can just plug in 4. What's 4 squared? 16 minus 12. 4 plus 7. So it's approaching 11. Now, there's no factoring here. There's no rational. It's not a fraction. It's not a what? It's not a radical. Are you going to have a vertical asymptote here? No, it's a parabola. That's why you need to know your family of graphs. It's not 16. It shouldn't be 16. Oh, they're going through it. Oh, my God, they're doing it step by step. What did we get?
We got 11.
There. Or you can take your handy-dandy calculator. If I could ever get out of here, and type in I'm going to go through these next time. I'm going to cut some of this stuff out. It's ridiculous. Y is equal to x squared minus 3x plus 7.
Vacation days.
I hate running this calculator with a mouse. X squared minus 3x plus 7. And there's the function, and all you have to do is go to the window, or go to table. What's happening when x is equal to 4? Where's your limit? That's a test question. Now you should be saying to yourself what?
Easy.
That's real easy. But I'm going to be surprised. I'm going to tell you a surprising revelation. There was one teacher that taught math 110 and 130 and 140. And by the time he got through limits, you couldn't even do this problem.
That's great.
Okay, we got a radical now. What happens with a radical? What can you not have under a radical? A negative. So you got to set equal to 0. So do that one. This is a test question because you got to use the dang old algebra. So go ahead and do it. Of course, none of y'all are saying anything, so that means you don't have any questions, so everybody should be able to do it. You know, I'm going to tell y'all a little secret. When y'all send me questions about class or class procedure, y'all are just hanging a sign around your neck that says, I don't look at your videos and I don't look at your handouts. I'm just letting y'all know that. Here's a recent email I just got. Y'all want to hear it?
Yes, sir.
It says, oh, well, this is, okay, this says, hello, sorry to bother you again. This student asked me if I averaged the test up or if I used the highest grade. So I didn't respond to that one. I noticed in the Unit 2 test that complete CTS in the parentheses beside it and was wanting to know what it meant. I don't know if it matters, but I don't want to be doing something okay, let me ask y'all a question. This is a college algebra. 109 students that I had, how many problems did we do with completing the square?
A lot.
A ton.
15 or 20. And what did I always use for an abbreviation for completing the square?
CTS.
So I did that the same way with my 110 last semester, and it's on the videos. So this student is basically telling me that she didn't watch what?
The video.
The videos, because she's asking me what CTS stands for.
Will you email her back?
Nope. All right, so what do we do here? Well, we're going to use our handy-dandy algebra, and we're going to set the denominator, or the radicand, equal to x squared minus 3x plus 2 is equal to 0. Use our reverse FOIL, x, 1, 2. That's going to be a negative and a negative. So I cannot plug in 1. I can plug in 1, or I can plug in 2. Everybody with me? So I go to my handy-dandy number line, and I put in 0, 1, 2. Now, what happens when I plug in 2? I'm going to get a 0. Everybody know that? When I plug in 1, I'm going to get a what? A 0. What happens when I plug in 0? What numbers do I get? 0 minus 0 is equal to positive what? So anything this way, I'm going to get what? Positive numbers. I can have positive numbers. That's good. How about 3? What happens when I plug in a 3? 3 squared is what? Minus 3 times 3 is what? Plus what? So I can plug in these numbers also. But what numbers can I not plug in? Well, let's see. How about a half? Well, if I plug in a half, or 1 1/2, which is 3 halves, then that's going to give me 9 halves minus what? 9 halves, but all positives. So that means with a square in here, I can plug in pretty much what? Anything. So I know that limit as x approaches 0. I know that this function, family of graphs, looks something like that, right? Yes or no? Square root function. Look at your parent graphs.
Should.
So what happens when I approach from the left and the right? What is my point? What am I, when x approaches from the right and x approaches from the left, what's my y? As x approaches 0 from the left and the right, what is my y? 0. So my limit is 0. That's another test question. I'm I'm sorry, I messed up. It's 2. I'm sorry, I messed up. Because it has a vertical shift of 2. My bad. I didn't even see the 2. Hold on. Let me fix it. I didn't do completing the square. I should have done completing the square. That would have given me my vertical shift. Sorry. What's my y-intercept on this function? My y-intercept is 2, right there. I think that's what you were saying. 1, 2. There we go. Now, as I approach x from the left and the right, what is my y? 2. And it's square root of 2, but that's the whole point. Square root of 2. Under the radical. Yep, I'm going to come in here next day or two, and I'm not going to say a word. I'm just going to look at y'all. Is that okay with y'all, Pendleton?
I guess so.
What the heck is the matter with y'all? I mean, do y'all do this in all your classes, Pendleton?
Yeah.
You do. You don't talk at all.